Hi, today we are going to discuss the percentage composition of a compound.
In this topic, you are able to determine how to solve for the percentage composition of a compound or substance. Calculate the percentage composition of a compound given its chemical formula. Analyze the percentage composition of different substances that you use in our daily life. Compounds. It is composed of two or more elements chemically combined in a fixed proportions, like water, H2O, salt, NaCl, and sugar, C12H22O11. So what is the percentage composition of a compound? Determining the percentage of each element present in a given compound is the percentage composition. It is also called as percent by mass. Remember, we are surrounded with different elements, and so different compounds. So how can we determine the percentage composition of a compound? First, identify the number of atoms present in given chemical formula. Remember that the subscript represents its number. When there is no subscript written in the element, therefore it is equivalent to 1 atom. Step number 2. Calculate for the total molar mass of the element. To do this, the number of atoms of element in a compound should be multiplied to the molar mass of the element. Step number 3. Calculate for the total molar mass of the compound. It is also called as the formula mass. Just add the total molar mass of all the elements. Step number 4. Apply the equation. Molar mass of given element in a compound divided by the total molar mass of the compound times 100%. Let's proceed by following those steps with water as an example. What is the percentage of hydrogen? And what is the percentage of oxygen in water compound? We all know that the chemical formula for water is H2O. In the periodic table, the molar mass of hydrogen is 1.01, while the molar mass of oxygen is 16.00. Let us solve for the total molar mass of each element in water compound. Hydrogen. 2, which is the number of atoms, times 1.01, the molar mass of an atom, equals to 2.02 atomic mass unit, and that is the total molar mass of hydrogen. Oxygen. 1 times 16.00 is equals to 16.00 atomic mass unit, and that is the total molar mass of oxygen. Adding the two is equivalent to 18.02 atomic mass unit. That is the formula mass of water compound. Next, applying the equation. Molar mass of the given element in a compound divided by the total molar mass of the compound times 100%. We have hydrogen is equals to 2.02 atomic mass unit divided by 18.02 atomic mass unit. We will cancel both atomic mass units since it is present in the numerator and the denominator of the equation. Multiply by 100%. We have hydrogen is equals to 0.112 times 100%. Or just move the decimal point 2 places to the right. answers is 11.2%. That is the percentage of hydrogen in the water compound. For the oxygen, we will use the same equation. Molar mass of the oxygen in a given compound divided by the total molar mass of the compound times 100%. We have oxygen is equals to 16.00 atomic mass unit divided by 18.02 atomic mass unit. Cancel atomic mass unit in the numerator and the denominator times 100%. We have 0.888 times 100%. Again, let's just move the decimal point 2 places to the right. That is equivalent to 88.8%, and that is the percentage of oxygen in the water compound. Using the pie graph, this shows that there is 11.2% of hydrogen element in a water compound and 88.8% of oxygen element in a water compound. Adding the two is the total of 100%. It also shows that oxygen is in greater percentage compared to hydrogen. This means that there is a greater amount of oxygen in a water compound compared to hydrogen element. Let's have another example. The chemical formula for sugar is C12H22O11. Using the following information for sugar, let's apply the given steps to determine its percentage composition. This time, we will use the table form. In the first column, we have the different elements present in sugar. In the second and third column, the number of atoms of each element and its corresponding molar mass. For the fourth column, we will get the total molar mass by multiplying the number of atoms and its molar mass. Add all the total molar mass is equivalent to the formula mass. Lastly, for the fifth column, apply the equation total molar mass divided by formula mass times 100% to get the percentage composition of each element. So we have carbon 42.10%, hydrogen 6.49%, and oxygen 51.41%. Remember that the highest percentage represents the greatest amount present in compound, which means that oxygen is present in greater amount compared to hydrogen and carbon. So, where can we use this? Do you eat eggs in breakfast? Did you know that there are a lot of nutrients present in egg? Eggs is the most common food humans eat, especially on breakfast. Eggs are a very good source of inexpensive high quality of protein and other nutrients needed by your body. 2 large eggs can give you 20% protein of your daily value needed based on 2,000 calorie diet. Now, are eating eggs good for you? Definitely yes. How about an apple? Do you know the nutrients that we get from eating an apple a day? Yes, water. But this 84.6% water present in apple contains phytonutrients and antioxidants that reduce the risk of developing cancer, hypertension, diabetes, and heart diseases. Now, is it true that an apple a day keeps the doctors away? Yes, it's true. Next, I have here the list of top 10 calcium foods. Which among the food we take give us the highest amount of calcium? You're right. The answer is milk. A cup of milk equivalent to 300 milligrams can provide you your 30% daily calcium needs. Perfect for your bones, and it's definitely a fact. But how did you know that you get the proper nutrients from the food you eat? Alright, check the label. These nutrition facts help us to better understand the content and nutrients of our food choices. So the next time you buy your food, always check the label. That's all for today.
So before I go, I'm going to leave you a little problem solving for you to try. Answer it correctly, let your teacher check and be impressed. Go carry on. Good luck and God bless.